This is a screencast. Just my mic. This is a screencast of me solving the next quest of Everybody Codes. As you can see, I've solved the first 5 already. Everybody Codes 2024. I'm going to solve quest 6. I haven't opened it yet. I don't know what it's going to be like. I have been doing these in Golang. So before I actually open up quest 6, let me go and set up the directory and set up a skeleton program. New folder. 6. And I'm just going to copy the main program from quest 5 on over. And this is almost certainly not going to be relevant. This will be 6 part 1. So if you haven't tried Everybody Codes yet, if you're familiar with Advent of Code, one notable difference with Everybody Code, the problems on Everybody Codes, is that they tend to make with each part of the problem a different input. So I end up grabbing the input 3 times. This is all stuff that is specific. Actually, all of this is stuff that was specific to the last problem, so I will probably end up deleting it later. For now, I'm just going to comment it out. But yes, I'll delete it later as it isn't relevant. Let me... Fine. Just do that so that it uses the variable and it doesn't complain about the existence of that variable. Okay, and initially I will put an exit there so that... Okay. I am ready to do what is needed with... Okay, and then part 1, I'll just fill in the code here. Total, or whatever. Okay. I'm just going to do this here, and why does it say I have 4 errors? I don't know why. No, it's only 1 error. Okay, right, let's get going and let's look at this problem. Quest 6. This beautiful tack sunny day. Beautiful and sunny day. I'm wondering if this was made by a non-English speaker. The tournament participants are directed to the royal gardens, specifically to the orchards where the trees cultivated for magical potions are meticulously tended to. Among the trees are the apples of superhuman strength. It's the potency of each apple depends on whether it shares the resources with other apples. Fruits with paths of the same length to the root share resources. If all branches were cut to ensure the final paths have unique lengths, the harvest would be drastically reduced. Okay. Actually, one path to a fruit with a unique length. Each knight approaches a tree and takes a moment to observe its branches. The root is marked with RR. Fruits are represented by @. Nodes are list of lines, each beginning with the branch name followed by a colon as a separator. After that, a list of branches or fruits they connect to separated by commas. The challenge for each night is to identify the path from the root that leads to the most powerful fruit on that tree. With paths of the same length to the root, all branches were cut to each tree path to a fruit with a unique length. Based on all the fruits except for one are located on branches of the same length relative to the root. The path to this singular most powerful fruit is RRB at. What is the path to the most powerful fruit in your tree? Okay, so we want a tree. Okay. Well, this is weird, but whatever. Okay, let's move the input file over. Okay, so actually let's just do this. Let's do new scanner. New reader. Okay. Yeah, let's just say new scanner. No. Okay, I can't remember what the thing is for. I can't remember what the Golang code is for a new scanner that's directly on the file, so whatever. We'll read the file into memory. It's fine. I should remember that, but I don't. Go is a relatively new language for me, as might be apparent. Okay, so then this format here is RR colon, a colon, and then a bunch of commas. So let's do paths, make map from string to slice of string for scanner.scan. Strings.split scanner.text tests strings.split 1 actually, then we just have paths split line of 0 equals split tests. Yeah, actually that is totally correct. Okay, so then what we want to deal with is we want to deal with paths that are from the start, or these RR. Okay, the paths do not include commas, so they're just that. Okay, let me just look at what our input looks like here just for a second. Okay, so they're all 2-character things. They're all 2-character things, so I'll be able to just concatenate them and compare length, and that will be the same as comparing the node length. Okay, good. So, right. Make map int string, and then what do? We start with RR and then we just split out. So actually let's do this. Let's not call grab ints. Let's do func yeah, all paths start string paths Okay, it was kind of a mistake to name this thing paths, so I'm going to call it network, and I'm going to rename it here. Okay, and then this is all paths that, so then we do for range map range network of start for res okay, wait, actually, if val, comma, okay, network, start, okay, then, okay, else return string. Okay, so for Next in range, not val, but what I want to do is, oh yeah, actually I do want to do this. For underscore, comma, all paths of string, all paths of val network actually that's wrong. I don't want val there, I want next dot append root val dot append slices dot concat string start okay, the path has to return a thing of string actually wait, no it doesn't. No, I want strings. Yeah, and what I want actually is I just want, because these are just paths that are being concatenated. Okay. One to path is that. For actually len to path bracket splen okay, and then ants, or actually ring or under path okay. Go run quest 6. Okay. Now, this is a kind of stupid way to do it, but okay. Part 2. Each participant first participant tree stand. first letters of each branch. Okay, so I'm guessing this will be much larger, and what I have done here before is not good. So I'm going to need a different data structure, I'm guessing. Let's look at this. Yeah. Okay. So this is a much larger and more complicated data structure. I'm guessing my silly thing won't work. Now, that being said, I'm going to try it anyway, just because, I mean, why not? Because if it works, then that's all we'll need. Okay, so we do that, we do P2, we do the scan. Yeah, so this part is going to be the same anyway. I don't know if this is going to work, but let me just try it. It would help if I actually saved the file, though. Okay, it worked really fast. So what I'm going to say is it says use only the first letters of each branch. So yeah, that was fast enough that I don't have to come up with a better data structure yet. If I don't have to, then I'm not going to. And then don't have what is this? Oh man, what is the Golang equivalent of question mark colon operator? Fine. Damn it. There are times when I think, as I'm writing in Go, this is way too verbose. There must be a faster way of doing this. And the answer is no. Now down here, abbreviations are false. And down here, use abbreviations true. And now let's just run it. Okay, good. I'll just put bugs and ants which resemble actual tree. Are only using only the first letters of each branch. What is the path to the most powerful fruit on the tree? Okay, so make sure I get the quest 3. Now, I'm just curious. So, okay, so quest 3 is much, much larger, but I don't know, man. It finished so fast before that I'm just gonna try this stupid. I mean, this is kind of stupid code here. Like, I'm not going to be putting this code, like, up for any awards, okay? This is kind of stupid code, but it seems to be working, so fine. Oh, shoot. I did not actually copy this code. There, select that. Copy. Paste. Okay. And now let's see if part 3, because yeah, I'm doing this. Let's see if it works. I gotta remember to save stuff before I run it. Okay, what would... Oh, duh. Yeah, I have that os.exit in there, so that... Yeah. Okay. Okay, frankly, I feel a lot better. I feel better that I finally hit this. So, okay, so now I do need a better data structure. So, what I was thinking I could do is yeah. So what I'm going to do okay, so first of all, we hit a stack overflow here. So the stack just got horrid. But I mean, that's just the stack. So maybe maybe if I do this same naive approach, but do it without recursion, do it so I don't use recursion, I don't actually have to get any better? It's kind of stupid, but at the same time, maybe not? Okay, I'm going to do this here. So, func find powerful. And this is just going to take network and abbrev, and it is just going to return a string. And so what we're going to do is we're going to create a work queue that it'll be things to work on, and we'll pull stuff off that. We'll check out the next paths, and we will push it back onto the queue. Yeah. So type qlm struct node string depth int pnode star qlm. Okay. And right, we'll do this and we'll, yeah. Okay. Sorry, I know that this is very, I'm doing stuff and I'm not really explaining well what I'm doing, but hopefully it'll become obvious. Yeah. Start is RR, depth is 1, although it doesn't really matter, nil. Previous QLM is nil. Now, what I'm going to do is for len q greater than 0, me 0 q equals q underscore comma next. Oh wait, if, okay, so also here I have var finals map int qlm. If val comma ok colon equals network bracket me dot node okay, we do stuff else finals bracket me dot depth equals append finals bracket me dot depth e. Oh wait. If val okay is equal to network and it's okay, then then for next range val. Okay, so I want to throw more stuff onto the queue. Q equals append queue of okay, I need a new QLM. So QLM next me dot depth plus 1 me ampersand me for use that. Okay, actually I'm just going to do var top node QLM for unknown files if when val equals 1 top node equals val bracket 0. Okay, now if top node is nil, oh, actually, yeah. Log dot fatal otherwise names, sorry, var names string for, actually, let's have this be ampersand. For top node bang equals nil names append top node dot node if is append, then now we do slices dot reverse names return strings dot join names Okay. Let's, okay, so what are your, oh, find powerful. So down here, okay. Okay, what is it? Assignment to entry in nil map. To entry in nil map. Ah. Right. I did not want that. I wanted that. So this is still not working. This is still way too slow. But we are doing the... So what could we do here? Well, obviously I think we have to not start from the root. Although I would have thought if this is just a tree that it'll be the same if we go forwards or backwards. But maybe it's not a tree? That is, it could be a directed acyclic graph, but not still not a tree. So, I mean, sure. Let me read this description again. Ancient. Bugs and ants. Make note of them. Okay, I'm gonna read that and see if those things actually show up in our input. Okay, so did we have anything that looked like a bug or ant? Okay, let's find out how long this thing is. Okay, so it's only 3476 lines long, so it shouldn't take that. It really shouldn't take that long. Okay, so we pop something off the queue. Okay, I'm gonna try something here. I'm gonna make sure that this works in our scenario 2. Okay, so that finishes fast, and it finishes fast with couldn't find a unique top node. Interesting. Okay, so actually what I want to do is I want to here. Print line debug I ling val. Interesting. So that's the debug in there, is that I find 2 nodes to all those things. Okay. Interesting. In the main one, here, okay, so oddly enough, I found this, and this doesn't match up with that at all. Well, that's not good. So next, me.depth ampersand me. So what if resemble actual tree branches. Okay. So, what I'm still wondering about is why this doesn't work for part 2. Because this should totally work for part 2. As well as for part 3, obviously. It doesn't work for part 3. So... kills eta depth plus 1. So for each okay, and then we'll just do here. Oh. Val, okay. But I really wanted to say here was me.node. Ha. Oh. Well, so what I should say is if me.node is an apple or fruit, whatever. Okay, so... Oh, whoops. Okay, so obviously that's a mistake, and I know what the mistake I made was here for top node and then top node equals top node dot pnode. Duh, of course. Okay, so we've got it so that it is working for part 2, but it is still getting bogged down in part 3 somewhere. Okay, so what is going on with... So let me just double check that it does work for part 2 still. Yeah. Yes, works perfectly well for part 2. Okay, so for part 3, we are getting bogged down here. Let me just do something where I do... dbg part 1 dbg me dot node length of q, just in case. ant bug, ant bug. Okay, so we're getting all these things that are ants or bugs. Okay. If val is not equal to ant and val not equal to bug, oh, well, not val, but what do we have? If next is not ant and next is not bug, then that. Yay! Okay, and I finished it in under an hour. Although my recording is close to an hour now. Okay, I will clean this up, remove the debug statements, and commit it and push it up. And let's see, hopefully this screencast will have recorded everything. Here. Is that enough to clean it up? Oh, okay, I forgot the dbg main bit. Okay. There we go. Well, that got a little further into the weeds than I wanted, but yeah. Good to know that you just wipe those out and then it disappears.